15. So 140 is nowhere here. So off to the side, we're going to make a factor tree. You take 140 and you're saying what times what equals 140 and is on this list. What two numbers multiply to 140 and is on this list? The answer is going to be 2 times 70. Unfortunately, neither one of those are on this list, but 70. That's 2 times 35. 35 is 7 times 5. So we're going to break this down. 2 to the square, because you have 2 of those, times 7 times 5. Notice none of these are doubled. So I'm going to rewrite this. I'm really going to rewrite this as 2 squared times 35. Since these are not squared, I'm just going to recombine them. Now go back to here. 140 is going to be 2 squared times 35, and this remains c to the 31st. Now we can split these up more. 2 squared, split up, square root 35, split up, c to the 31st. 2 squared, so there's a 2, invisible 2 here, 2 here. Those cancel out, so 2 comes out of the radical. 35, there are no perfect squares, so they're going to stay where they are. This c to the 31st, there's an invisible 2 here. You divide 2 into 31. So you write the base. How many times does 2 go into 31? 15 times. And you have 1 left over. So the 2 goes into 31 15 times. You have 1 left over. This leftover will stay in the radical. Okay? So I'm bringing the 35 down again. I'm bringing the c down, and this 1 is this 1, which you don't have to write necessarily. But I want you to realize that this 2 goes into 31 15 times, so that comes out of the radical. 2, this index goes into 31 15 times, and there's 1 left over. The leftover stays in the radical. The 35 is a leftover, stays in the radical. Now, sometimes the software, when this variable is odd, because they want to make sure that it stays positive, since everything in this radical has to be positive, they'll put these in absolute value. Here's your 35, and here's your c. You don't have to put the 1 power there. This is what I'll put in for my final answer. This could usually work, but sometimes they like having the odd exponents in an absolute value. And if the c is to the 1st power, you don't have to write the c there. Okay, let's keep it going. 3 is a to the 11th, b to the 7th. Let's say you want to simplify. Everything is being simplified. Product rule breaks these up. A to the 11th times b to the 7th. how to break these down. Invisible 2 here, invisible 2 here. So if the index goes into the power, something's coming out of the radical. The base is coming out. 2 goes into 11 5 times. There's 1 left over. So just the A by itself. 2 into 11 5 times comes out of the radical. 1 left over stays in the radical. And now let's do the same thing for the B variable. 2 goes into 7 3 times. B to the third comes out of the variable. And what's left over? 1 is left over. Let's take this a step further. Those are the 2 items out of the radical. So they both have odd exponents. So it's preferable to put these in absolute values just to make sure that these are positive. The leftovers, the A and the B, both have to the first power. So you don't have to write the first power there. That's your answer. Now you could try this without putting the absolute values in first. See if the software likes it. If there's any problem, just put them back in. And we keep going. It's 10 minutes and 36 seconds. So I'm going to stop this and we're going to pick up again in a few minutes with example number 4.